Day 2, we're going to take a look at chapter 2. Again, I'm going to run over it a little quicker this time. Try to fill in some blanks that we didn't get from Tuesday, and then we'll end with an assignment. And then on next Tuesday, what I'm going to do is basically the next couple of chapters you're going to be working on in groups. Tuesday is going to be a worksheet, and we're going to be covering chapter 3. Thursday will be programs that I want you to do for chapter 4. And you're going, oh my God, he's not going to teach us anything. Well, yeah, chapter 3 worksheet is a worksheet where you're going to be writing code to handle if statements. You're going to build on that. Chapter 4 programs are going to be a bunch of mini programs you're going to work in a group to do loops. So a couple of things that are going on is, you're starting to learn each other in class. You're reviewing what you did conceptually in Java, but you're also learning how to do it in C++. Right? So let's go through chapter 2, fill in some blanks. As I told you, the PowerPoints are available under content for you. Anytime you want to grab them and look through them, you can. Another good feature of good students is, and you basically get some of this with the code listings, but as you go through and type those, it's almost like you're reading the chapter, and it's always good to read ahead and highlight, make some notes. If you buy the book, don't if you rent it. All right, chapter 2, parts of a program. We're all good with this. I mentioned about the preprocessor directive. You're really learning a new language. Like, I compliment folks in my 121 class online, because they're like, well, I'm from this country and I speak this language and this language. And I'm like, that's great. And now you're going to learn a new language, Java. Now you're learning a new language, C++. And along with this comes a lot of this terminology, like a preprocessor directive. So you need to learn the verbiage so you can talk the talk. Okay. You also know what a string literal is. We have a beginning left brace and an ending, what we call right brace, beginning brace and left. Do you notice Gaddis finally does what I want him to do? He lines them up, the left and the right. In the Java book, he put that left brace on the previous line. I never liked that. If I ever met him, I'd like to tell him, because I need folks to line them up so that they can keep track of them better. Special characters, same as Java. Nice. The C out statement. Programming is fun, easy. We learned about having to put this insertion operator, right? The stream insertion operator, so that we can display things. If we wanted to display different things all within one line, we'd have that multiple C out operator. Is that a good term to call it? What should we call this? Can we give it a quick name, or less than works? We'll go with less than. Okay, and here's an example. Hello there, hello there. Looks pretty good. They would both display outputs side by side. And programming is fun. See it in every programming textbook you ever have. I'm looking down in my left corner, slide 8 of 76. Oh, all right. Endlin, yes. I say Endlin. Most people say Endlin. Some people say Endl, to make sure that that is not confused by the number 1. It's ENDL. Okay, so I can get 2 separate lines of code. You see the example. It's all lowercase. Everything's good. We talked briefly about the escape sequences, how we throw it in and it puts the carriage return in. So a quick conversation. What is the term carriage return mean?
Like your string will start on the next line, basically. Okay.
Nathan, you have a little more history for us?
Technically, that's like an old thing back when ASCII was used for like sending telegrams. Okay. It literally means like send the typewriter carriage back to the beginning, like
there
use
you
the typewriter
go.
like
way back in the day when I was in 9th grade, we still used manual typewriters, and the manual means it wasn't plugged in, it wasn't electric. You didn't hit return and did what you wanted. You had to push that the bar that the paper was wrapped around called the carriage, and you had to get the little handle and return it. And when you returned it, it clicked and moved to the next line. So that's where the term carriage return comes from. Okay. One of the things about the pound include statements, like we already use iOS stream because we know we need that for input and output. Just make sure you don't put a semicolon at the end of that line. Something to get you messed up with. As you learned in Java, the semicolons are important and where you put them. Okay, we know what a variable is. Int item looks pretty good. We have the string literal versus an integer literal. Not too bad. These PowerPoints are pretty clean, quick, and clear. It's what we did in class. You know, you have 10 minutes before a class and you know what's coming up. You can watch the PowerPoints, run through them pretty quick. There's another example of multiple lines. Things that you learned are putting a space at the end before the double quote so that it looks nice. Not too bad. Identifiers, we talked about. These are the keywords. They're the ones that are in lowercase. And I think when you type them in, what color are they? Are they purple? I don't remember my IDE right now. But anyhow, they're keywords. They in Pascal, when we used to teach Pascal as our intro course, we called these reserved words, meaning those are words you cannot use as a variable name. But there was also a list that was like semi-reserved, but if you really wanted, you could take it and use it as a variable name. Never understood why Pascal did that, but Pascal was a nice little neat language that I liked working with. Items ordered, that's our camel case. You all got that. The rules must start with either alphabetic or underscore. After that, it can go alphanumeric with underscores. And finally, the third bullet, yes, it's case sensitive. Good and bad ones. Good, no for the period. No, can't start with a 4, and no special characters like a $sign. And you all keep it pretty simple. I mean, the most common one is the camel case. Integer data types. Here we go with the integers. Short int. Well, as I was referencing Pascal a minute ago, in the days of Pascal, our integer data type was only 2 bytes because we never thought we were going to do much work outside the range of that negative 32,768 to 32,767. Okay, so how does that work out that that's 2 bytes? Well, if I added those two numbers together, it basically becomes this guy, 65,530. If I add the one more to that, 36. Now, what is 65,536? Well, if I start using my fingers, I don't know if you can see my fingers or just my screen, but I go 2, 4, 8, 16, 32, and then I start with the next hand, 64, 128, 256, 512, 1,024. Oh yeah, we knew that was 2 to the 10th. 2,048. 4,096, 8,192, 16,384, 32,000, blah, blah, and then one more gets me to 65,536. So 65,536 is 2 to the 16th power. And 2 bytes is 8 and 8. And that's base 2, 8 and 8 is 16. So 2 bytes will give me that range of numbers, that 65,536 total digits that I need. And you know, the short int splits them, and then unsigned int makes them all positives. So really, if I took a look at int, which is 2, it's like what I'm going to win in Powerball coming up, that much number. Yeah, -0. It's like 100,000, 5 billion. So 2 to the 32nd power should be 5 billion or 4,294,000,000. Oh, it's right below in the unsigned one. Will you ever need anything bigger than that in int? Probably not. And that's why we're safe with int. for almost everything we do, we could go short in it, but it's not like the old days when memory mattered. Okay. We can declare them on separate lines. We can declare them on the same line. You already know that. 3 variables declared here. That's called my declaration section. It's where I declare my variables, lines 7, 8, and 9. And then we start assigning values. Again, this is the assignment operator. The equals is the assignment operator. An example, are the PowerPoint pages popping up instantaneously, or is there a lag? They're coming up pretty quick.
Not noticing any lag. I think you're good.
Good. So if I go now, you see 2.7?
Yep.
All right. So we talked about int is one of our primitive. We talked about char. One of the neat things, we're remembering that it's going to be in single quotes, is I can say char letter equals A, or I could say, we'll get into strings later, or, oh, they didn't have it in there. I could have said letter equals, what is capital A in the ASCII chart? Does anybody remember?
65.
Excellent, 65. I could say letter equals 65, and it would automatically make it a capital A for my output. There's an example of that in the textbook. Okay. The next one is character strings. These are called C strings. We're going to get into those, and most of you aren't going to like it. That goes back to old school C instead of C++. But we're going to have these arrays of characters, and we always have to have a /0, the null terminator at the end. So we're going to get into that in a couple of chapters. But this was old school. This is how I had to handle strings. Somebody was nice enough to write us the class string so that we can work with string and do all the stuff we want to do with string and all of the functions that go with it. Remember back to Java, the methods that went with string included length. You know, all of that was written. In the old days, we had to go through and count by hand. Yeah, I remember those old days. It's much easier now that somebody created a class and it's automatically included in C++. All right, string wheels of fury. All right, so we're over halfway. Floating point. This is my third one. We mentioned this the other day. Yeah, boy, 4 bytes, 8 bytes. We use double. We'll never have any trouble with anything but double. If you wanted to use less memory, you could use float. And some examples. Here's a program with an example. Bool. We talked about bool. True or false. Okay. This is another of our original data types. Okay. And there's an example. It gets the value of either true or it gets the value of false. You notice when we print it out, we get a 1 or 0. Determining size. Here's a function that's available to you if you ever wanted to check on the size of a variable. Don't know why. Yeah, there's 1 or 2 times that you might use it, but you can use this function called size of. You notice I'm doing really well calling them functions in C++. In Java, they were methods. In C++, we call them functions. All right. Assignment operator, item gets a value of 12. Documentation, right, we always work from right to left. Everything's still good. We're just rolling right along, and we got some good stuff going on. Doubles getting the value. I don't even know what the keyword is, auto, so I'm not even going to discuss it. Scope. Scope of a variable is how long we use it. You learned back in Java, I could declare local variable in a method. And when I left that method, the variable was gone. So its scope was only in that method. So that's where this term scope comes from. And we got into some arithmetic operators. We looked at addition, subtraction, division. 7/3 is 2. And when I divide it, I have a remainder of 1. Okay, and there's an example. We had some crazy examples as well. We talked about the difference between integer division and floating point or real division. There's the modulus going to town. Only works with integers. 5 goes into 13 twice with the remainder of 3. Documentation, same as it ever was. I can document at the end of a line with the double slash, or I can start and end with the slash, asterisk, asterisk, slash. All of you are going, yes, we're in day 2 and I still have a strong A in this class. That's good. Named constants. So one of the things is if you were writing a really long program and you had a tax rate of 0.0675 and you had to use it several places in the program, you might want to make a variable, make it constant so it can't be changed, and then reference that 0.675 throughout the program by tax rate. Because what happens if this ever changed? Instead of having to go through the program all over the place and change it, you would only have to change it in the beginning. So we can declare it, we can throw const in so that it doesn't get changed anywhere in the program by accident. And there was an example, programming style. You all know style about indenting, adding spaces, so on. Questions? Still have 26 folks here. That's good. Nobody left and quit on me. All right. So you did a program on Tuesday, and it was one where we dealt with Let me go back and see if I can find it. Where is my I think it's, if I share this, I don't really want that. It wants me to stop sharing. I'm trying to get to the program from last class. You wrote a program. Let me try going in here. There we go. Are we better? In D2L?
Yep.
Okay. Coming in, yeah, this is funny. I thought this was funny. So I put it on there, but I always answer emails. But this is for me to say, there are sometimes you have questions. Go check the syllabus first. Down here in the lower right, here's a widget that I said I would put in to add the classroom videos. That was classroom day 1, chapter 2. We're going to have one for today as well. And I went to the discussion board. Still good. And I went, woohoo, we had some folks that actually did display the hours, minutes, and seconds. So as you can see, this isn't a whole lot of code, okay? Not a lot of code. Once we did the algebra, it was all good. Now, Nathan posted this and displayed it. I actually prefer when people will send the .cpp file. That way I can download it and open it and use it instead of
So
cutting.
I did include that as well.
Yes.
But I'd also included like
right here. Right there. I'm sorry.
yeah.
Right there. Yeah. So good. It's easier for you folks to work off of each other with the .cpp file. Just throwing it out there. Not a bad idea to display it because I can come in and look.
Yeah, I noticed it like ate the tabs when I pasted it in there.
Yes. Yes. And that's why we can't cut and paste from like Office. You know, if we go into Word and get something out of there, because there's invisible characters that transfer and some don't transfer. And as you can see, the tabs didn't transfer. And that's why sometimes when I get students who submit a program without any tabs in, I'm like, well, did they copy this from somewhere? Because there's no indenting, which is usually a clue. But here you can see he put this in. And also he posted for us the examples we were talking about the other day in class. It was like our class notes. So thank you for that, Nathan. Thank you as well for Mohammed. So now I want to go and look at this and say, okay, so you did this and you have int second equals 1000. Well, we know C out was what I had to use to display something. So it's nice and easy in C++. If C out is used to display, what would I use to input something from the keyboard? Well, if it's not C out, it's probably going to be C in. So what I'm going to have you do now is I'm going to come back to here. I'm going to have you grab your books for a second. I want you to look at section 3.1, and it's going to have you deal with C in. So instead of your program hard coding in the number of seconds to start with, I want you to ask the user for how many seconds it would be, and then let them input it. So add that to your program, picking up from where we left off on Tuesday. Questions? Okay. Excuse me. So if you have 4 for loops and you do int CTR in the first one, you're looking for a memory spot. And then in your second one later, if you do it again, you're looking int CTR inside of it. You're creating another. So you will have gone through and created a new memory spot, new memory location for each time you reuse it. Lags it a little bit. 6 of one, half a dozen of another. But I will tell you, and I'm not sure what IDE for dev C++, it won't let you do that. It won't let you do for int x equals 0, ... It won't let you do that declaration inside. But I'm not positive which version. So I did see that, just to keep your eyes open on that. Okay. Good discussion. So we have the C out involved. Enter the number of seconds you want, and the way this looks like it's going to run, it's going to keep it all on one line. Okay, and he puts 20,000 seconds, and it looks like it's going to be 5 hours, 33 minutes, and 20 seconds. Now he's going to run it again because we did have that test data. We had test data made up that included numbers like 61. You don't have to keep enlarging it. 61. Okay, I feel good about that. It's 1 minute and 1 second. You know, that's our digital clock appearing. And everything looks good, and we're off to a good start. All right, if you want to stop sharing, I'm going to come down and put my dock camera on. I'm going to come down and put my dock camera. There we go. And I'm going to change my view to speaker view, put it on me so I can see this piece of paper. Everybody can see it. All right, so I'm going to have you write, excuse me. Darn peanut. I'm going to have you write another program. I'm going to put you in smaller groups today, probably just like 3, maybe 2 and 3. And I want you to practice writing another C++ program. Well, you can write this in Java. What do I want you to do? I want you to tell me, how many bags of mulch you need. So I'm going to say, you're going to ask me for dimensions. You're going to ask me for the length. You're going to ask me for the width. You're going to ask me for the height. And then you're going to display, here's how many bags you need. Something along those lines. Now, how much mulch is in a bag? 2 cubic feet. 2 cubic feet. You're going to ask the user length in inches, width in inches, height in inches. You're going to tell me how many bags I need. This can be a decimal. 4.02 or whatever comes out. You don't have to worry about rounding up or any of that. So I'm going to put you in your groups. The first thing I want you to do is, as a group, come up with some sample test data. Second thing I want you to do is start to write pseudocode. Okay? Input L, input H, da 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 da. Then you're going to call me to your breakout room. You're going to show this to me and I'll say, okay, go ahead. You can write the program now. Now, where are you going to do this work? You probably don't have a doc cam, but one of the things you should be able to see is if you go to share your screen, one of you in the group share your screen, you should be able to see a whiteboard that you can get ready and get the whiteboard. Some of you can do that. There's lots of different ways that you could come up with this, okay? But that's what we're looking for. Questions? I'm going to stop the recording.